Now that we've learned some of the atmospheric components of weather, let's start looking down in the nitty gritty in the thunderstorms and the precipitation in some of the different hazardous type of weather. So let's start with the basic thunderstorm here. And for any type of thunderstorm, you need three ingredients to form a thunderstorm. So you need moisture, you need something called instability, and then you need a source of lift. So for the southern United States, a lot of our moisture comes either from the Gulf of Mexico, up over Texas in to New Mexico, or from the Pacific Ocean, depending on the wind and what direction that moisture is being pumped in from. For instability, that's just a fancy term for unstable air, basically the energy built up in the atmosphere. Heat can do that, different wind shear and different components around low pressure systems can build up instability. So we need that. And then we need a source of lift. We need a way to get all of that moisture and instability going upwards in the atmosphere so that it can condense and basically form those thunderstorms. So that can either be daytime heating, as in the sun can cause that lift. Remember that warm air rises, so as the sun heats the earth, that air begins to move upward. Fronts and low pressure systems, we've both learned, cause upward motion. And terrain, if you get air being forced up a mountain, that can also be a source of lift. So if all three of these things line up, then most of the time we get thunderstorms. They begin as what's called the towering cumulus stage. Basically, you just get a really tall cumulus cloud that's starting. All of the air motion is upward. We call that an updraft. So all of the air is moving up into the thunderstorm. And you can think about this as the fuel for a thunderstorm. The fuel for a car is very much what all this air is to the thunderstorm. So you can very much think of a thunderstorm as a car here for this example. And the water droplets begin to grow as the cloud forms. So we don't really have rain yet. All those water droplets are still small enough to just be basically cloud droplets. Nothing is falling down yet. The mature stage of these thunderstorms is you get what's called an updraft and a downdraft going at the same time. So that's the upward motion of the air fueling the thunderstorm. And then the downdraft is all of the air and the rain and the hail falling out of the thunderstorm. So you have both an updraft and a downdraft, and you can think of that downdraft as the exhaust from a thunderstorm. So that rain-cooled air is being pulled down, and then when it hits the surface, it spreads out in all directions. So then you have basically a mature thunderstorm going where the updraft and the downdraft coexist. So air moving upward and moving downward in a thunderstorm at the same time. The thunderstorm begins to weaken though, because as that cool air hits the surface, it spreads out in all directions and cuts off the fuel of the thunderstorm. So just like if a car runs out of gas, it stops working. When that fuel, that warm, moist air, gets cut off, when it disappears, the thunderstorm begins to die because there's nothing left to fuel it. So you basically just get this weakening dissipation stage where you get the thin, wispy clouds and maybe some leftover showers, but nothing much left. And that whole process actually only takes 30 minutes to 60 minutes. So it can be a quick-lived thunderstorm going from just a couple of clouds to the mature stage to the dissipating stage. The big thunderstorms, the ones that produce the tornadoes, the large hail, the damaging winds, those are called supercells. And so we need a fourth ingredient for these supercells to form, and that's called wind shear. And basically you can see that here with these arrows. The wind is light at the surface and a lot stronger up in the atmosphere. And what that does is that allows the full thunderstorm to tilt and for the downdraft to fall away from the updraft. So what that does is that means that all this cool air falls away from the updraft, and so basically the exhaust never cuts off the fuel. So you have an infinite fuel source for these supercell thunderstorms. So they can last for very long periods of time because they can continue pulling in the fuel, and that fuel source does not get cut off, all because the thunderstorm is tilted. So this is kind of a conceptual model of what a supercell looks like. So you have the updraft here in the center with the downdraft falling away from it. The downdraft again is where all of the heavy rainfall or the hail might be. The updraft is where all that upward motion is, and it can actually punch through to the next level of the atmosphere, up into the stratosphere if it's strong enough. There's that much air moving up into the atmosphere that it can actually punch into the next level. The updraft is also where the tornado would form if there was going to be a tornado. And there's so much air moving up that there's actually no rain under the updraft. So, a quick way to think of a severe thunderstorm or a supercell is that the updraft is where the tornado might form, but there's no rain there because there's so much upward motion fueling the thunderstorm. The downdraft is the exhaust, and that's where any hail, a heavy rainfall would fall out of the thunderstorm there in the downdraft section. So thunderstorms, both those run-of-the-mill ones that last only about an hour, and these supercells produce lots of different threats. The main one being lightning. Flash flooding is a threat. Large hail. There's a picture here of some 1.5 to 2 inch hail that's getting up into the golf ball and near baseball size hail. Damaging winds. This is what's called a microburst coming down out of a thunderstorm. Think about opening a faucet and just all of that water gushing out of a thunderstorm. That's basically what a downburst is. It can cause winds of 70, 80, 90 miles an hour. And of course, tornadoes is another severe thunderstorm threat. So here's an example from Central Texas of what they look like on radar. So these are those run-of-the-mill thunderstorms. So if you notice, there's a lot of reds, a lot of yellows, and as this thin line, which is where the colder air, where the exhaust is, gets pushed out ahead of the storms, they weaken. So these are those ones that are only going to last about an hour or two, where they strengthen to the mature stage and then begin to weaken as that fuel source gets cut off and the exhaust takes over the thunderstorm. This, though, is a supercell. So if you notice here, here's actually a 3D depiction of what this radar image is, and notice the tilt of the thunderstorm. That's again because of that fourth ingredient, that wind shear, allowing the downdraft to fall away from the updraft, allowing all of this hail and all this heavy rainfall to fall away from all that upward motion, and the storm just continues for hours and hours on end. It moved all across the city of San Antonio here, and this supercell thunderstorm actually dropped 4-inch and 4.5-inch hail, so thinking baseball to softball sized hail across the north side of San Antonio. So that's a brief overview of regular run-of-the-mill thunderstorms and supercell thunderstorms.